geometric series and sequences and series, however you want to offer that up. But remember, we have arithmetic sequences and series and summation. You're going to see a lot of similarities here with the geometric stuff. So recall, our geometric sequence formula, a sub n equals a sub 1, the first term, ratio times, I'm sorry, not times, raised to power of n minus 1. So we got the ins and outs of this stuff already, so we're going to jump right into some examples. So let's start with this one. All right, let's say Lauren forwards a Twitter meme to 4 of her friends. And I'm sure we've all done this at one time or another. And then each one of those friends, each friend forwards it to 4 of their friends, and so on. If the pattern continues, how many people will receive the meme on the 9th round, or in the 9th round, if you will? So, how's this going to work out? What are we going to end up doing here? So let's see what we can do. First off, we want to label everything we got. It's going to be a geometric sequence as we do this. So we got a sub 1, which is equal to 4. Each person's doing this 4 times, and in terms of 4 my friends, 4 my friends, 4 my friends. So R is equal to 4, and we want 9 rounds of these forwardings going on. So we got 9. So our formula, a sub n, a sub 1, R to the n minus 1 power. So let's plug stuff in. We're going to have first term, 4 of our friends. The rate is 4. And then we want the 9th round, and that's 9 minus 1, which will give us 8. So 4 to the 8th power, 65,536. And then we got to multiply that by 4. So a sub 9, in other words, in the 9th round of these forwardings going on, and everybody does to 4 friends, my 4 friends to their 4 friends, and so on and so on and so on, means what? 262,144 people will receive the meme. I don't know why I went lowercase there for some strange reason. So, you get those chain letters or chain text messages, send this so and so many people, and everybody does that. Just in 9 rounds of doing that, that's how many people have been, or have received it, been affected by it, if you will, so to speak. Look at this one. All right, this one's a little more textbook kind of deal problem. You want to write the geometric equation, or equation, for the nth term of the geometric sequence. Sorry, I got a little ahead of myself on that. Okay. Well, what do we need? We need a sub 1, we need R, and we need N. So let's see what we can come up with. So we look at the 2 terms here, and we start setting them up. 2 divided by negative 0.25. See if we get something there. Negative 16 divided by 2. See if we get something there. And we get a negative 8. And we get a negative 8. So we know R is equal to negative 8. Okay. Do we have a first term? Why, sure we do. Negative 0.25. What don't we have? This. Are we going to be able to get it? Probably not. Notice what the question asked. It wants us to write the equation, so not an answer. Write the equation. Okay? So a sub n, a sub 1 times r to the n minus 1 power. So let's see what all we got. Let's plug our information in. A sub n, depends where we want to stop. Negative 0.25, a sub 1. What's our ratio? Negative 8 to the power of n minus 1. We don't know n, so there's your equation for that sequence. That's your equation. And then depending where you want to stop or whatever the problem says, you plug in the appropriate information, and boom, we got it. All right, let's look at letter B here. See what we got. We got a sub 3. We've got r. Our formula is this. A sub n, a to the first term, r, and then n minus 1. So we've got some different information here that we can try to figure out. We know that the third term here, okay? So if this is our third term, let's go back and figure out our first term. So if we only go to 3 terms, 16 is equal to, we don't know our first term yet. We know our constant rate, or I keep saying rate, sorry. Our ratio is 4. We got n, remember, going back, a sub n is 3 minus 1, which is 2. So what's it tell us? 16 equals 16. A sub 1. A sub 1, in this case, happens to be 1. Use this to make our general formula. Our series isn't stopping at 3, we just happen to know the third term. So a sub n equals 1 times the quantity of 4 to the power of n minus 1. A lot of times you probably won't see that. I'm putting in there because I'm being very particular with our setup as to our. All right, you remember arithmetic means? Well, there are geometric means as well. Our definition: geometric means would be terms that are in between two non-consecutive. Terms in between, or means in between two non-consecutive terms of the geometric sequence. So let's look at a problem here. And again, we've got our handy-dandy formula, a sub n, and that's equal to a sub 1 times r to the n minus 1. Let's see what we got and work ourselves through this. So we want to find the 4 geometric means that are between 1/2 and 5/12. Well, that's a serious jump. So let's see. And it's only 4 jumps to get there, 5 jumps technically. So there's our a sub 1. In this case, a sub n, we're stopping 1, 2, 3, 4, 5, 6. So we're stopping here at the 6th place. And we're going to here, to boom, 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 and then we're getting up to 5/12. So let's take that information that we know and plug things in. A sub n, 5/12. That's what our pattern stopped at that we have right now. Equals, we know 1/2, a sub 1. Our ratio is what we're trying to find here. So we'll have r to what power? Well, there's n minus 1. So 6 minus 1, 5. So 5/12 equals 1/2 times r to the 5th power. Okay. First step, multiply everything by 2. 1024 equals r to the 5th power. Next, we are going to 5th root everything. Use my calculator. Figure out what times itself 5 times is 1024. We find out that the answer is 4. So we're going to use that to find our next 4 terms. In other words, take 4 times what previous? 4 times 1/2, 2 times 4 is 8, times 4 is 32, times 4 is 128, times 4 is 512. So our geometric means are as follows: 2, 8, 32, and 128 in this particular example. Okay. Next. Again, should look familiar. It's just a little bit of a different formula than we did with the arithmetic means. Let's look here. When we have a geometric series, it's going to be the sum of all the terms of a geometric sequence, or the partial sums, because it'll be not the whole thing, but it'll be in between two given quantities. Now, as we do this, there's 2 formulas we could use, dependent on what you're given. So if we're given first term and n, where we're trying to end this thing, or how many times, then we'll use this partial sum. There's our formula. Now notice it's n here, and not n minus 1, 1 minus r. Can't be 1. We all should know why. If you're given the first term and then the whatever term, now your formula changed a little bit, so please look. Partial sum. Now it's a to the sub n times r. There's no exponent. 1 minus r. So you got to keep them straight because they're very closely related to each other. So it'll be important for you to have those down. And again, what am I given? There, use that one. Am I given this information? Use this one. So you got to pay close attention to given info for your formulas. Let's look at a couple examples through this, please. Okay, let's go back to our Lauren problem. So she had 4 memes to give out to 4 friends and so on. 9 rounds of the forwards were going on. What will the total number of forwards be? Total number of forwards now, not the total number of people involved. This will be the total number of forwards that were taking place. So you got to pay attention to that just a tad. Excuse me. Oh, there we go. So let's look at what we got. We got what we started with, a sub 1. We got r. And we've got n. We got 9 rounds that we wanted to take place in. So our sum, our partial sum, will take on this. A sub 1 minus, what do we got? Still got our first term. We got r. So to the power of n all over 1 minus r. So plug in now. 4 minus 4 times the power, times again 4 to the 9th power all over 1 minus 4. All right, work being done. 262,144. All that's over -3. So when we do all this fun stuff, our final answer is this. And again, we're figuring out the number of forwards now, not the number of people involved, because remember, each person's doing 4 of those things. Oh, check that. No, I did that wrong. Sorry. 524 forwards. My bad. 524 forwards would take place. I don't know if you saw on Twitter, there was another little thing going on with people were saying give 5 words and 5 tags. So, you got to say 5 words about something and then tag 5 people, and kind of a similar deal. So 5 words, 5 tags. Let's say we want to look into 12 rounds of this. Okay? So what do we got? Well, we've got a 5. Instead of 4 forwards, we got 5 of them. So we're tagging 5 other people in our tweet. And then 12 rounds. So 1 is equal to 12. So let's plug this bad boy in. S sub 12, because we want 12. 5 minus 5 times 5 raised to the 12th power, all over 1 minus 5. As you can see, calculators are going to be quite handy. All that's over -4. Let's cut to the chase and use our calculator a little bit more. So we're going to get 305,175,780 total tags in this. Total. That's how many tags took place in all that. How many tags were taking place. Okay. Oh yeah, lots of examples here today. Okay, so here's what I want you to do on this one. On these next 2 examples, I'm not working through them right now. I want you to take some time, stop the video, instead of just listening to the video all the time. Stop the video and you work. I need you to find the sum of each geometric series here. I'm giving you a sub 1 equals 2, n is equal to 10, r is equal to 3. Figure that out. I'm going to give you first term 2,000, a sub n now, 125, and r is equal to 1/2. So I've given you those. Put pause on here. Go through and work through these. I'm going to do a dramatic pause, but I'm going to put the rest of my notes in here as well. I'll have the answers to those as I follow through. But again, instead of just sitting here listening all the time, pause it, go work on it, and see if you come up with the right answers. Sigma notation. You saw this with the arithmetic sequences. Same thing's going on here. With our sigma notation, first value of k, last value, whatever that happens to be, and there's our formula for the series. The notation is going to be the same for both arithmetic and geometric. F of x is what makes the difference. F of x is what makes arithmetic or geometric. And the key would be looking for signs inside the function. So I'm going to give you this example as well, like I did with the other 2 on this page, and work through it. I'll have the answers worked out here eventually. So look what we got. Need the summation of this function from 3 to 10. Summation of this function from 3 to 10. So the first spot is going to be 16. Plug in, do the work. That'll tell you, because we started when k is equal to 3. So we plugged it in here. We get an answer of 16. So we know a sub 1. The base of an exponential function is r. And the exponential function will be r. So we know r is equal to 2. And from 3 to 10, this is 8 spots. Remember, you got to count the spot that you're starting with. So n is equal to 8. So here's our important information, all coming out of this. So that tells us we have to use this formula. So again, take a moment and come up with your answer. Actually, I wanted you to do this one. We were just figuring out the formula on the other one. We can go through that. I would like you to do this one as well. Now I want you to find the complete summation from 4 to 12 of the geometric function 1/4 times 3 to the power of k minus 1. So give that one a shot and see what you come up with as well. Here would be your answers to A. Working through our steps all the way through. Here would be your answers to B on that given information. And the last example I put up would be here. In the first summation example, your answer would have been 4,080. 4,080. Well, there's all your examples and your answers. Make sure if you're having questions that you please ask.